Hey you guys, good morning. I hope you guys are doing well. Today I want to talk a little bit about measurements, taking measurements and some aspects of measurements. First of all measurements have a number and a label or a unit. So for instance, let's say 2.5 centimeters. So if you guys remember from your scientific method virtual lab assignment that you were measuring the flowers, and you guys did a really good job. I only had a few that were missing labels, but you had a numerical value and then you had a label to go along with that. And that label means a lot. It tells us what our measurement is. Is it length? Is it mass? Is it volume? Is it temperature? So having a label on your measurement is very important. I want to talk a little bit now about precision and accuracy in measurements. First of all, accuracy is a measure of how close the experimental value is to an actual value. So let's say, for instance, I go ahead and I give you a beaker, and I tell you that the beaker is 50 grams. And then I tell you to take that beaker and put it on the balance and find out the mass of the beaker. If you put it on the balance and you find out that it is 50 grams, then you could say that you are accurate or you have accuracy. Okay, this is the given value and this is your experimental value. So if the two values match, then that means you have accuracy or you are accurate. Two ways you can look at precision. Precision you can think about as two definitions for it. The closeness of a set of measured values to one another. So 9.75, 9.74, 9.76. The fact that each of these are off by just a few tenths of a gram means that my group of measurements are precise, or we have precision. If I had values like 9.6, 4, 9.99, 10.02, if my measurements are very far away from each other, then that means that we do not have precision. Another way to think about precision is the exactness of a measurement. So more places past the decimal, the more precise my measurement is. So if I say that something is 5 centimeters, that's not a lot of information. That's not very precise. That's almost like an estimate. If I say something is 5.5 centimeters, that gets a little bit more precise. It tells me I have more information about my measurement. If I have a value that is 5.56 centimeters, now I'm getting even more information about my measurement, and I'm getting more precise. If I have a measurement that's 5.425 centimeters, I have even more information and I even have more precision in my measurements. A place that you guys might appreciate or might understand precision, the second definition especially, is if you've ever seen a home improvement show, think of any renovations that may have happened in your houses. The contractors have to be very precise in their measurements, or else all of the things in the kitchen or the bathroom, whatever you're having remodeled, isn't going to fit. If your builders and your contractors are using measurements that are very imprecise, not precise at all, then all of the things that they are redoing and they are putting back into your kitchen or back in your bathroom are not going to fit. So the more places past the decimal in a numerical value or in a measurement, the more precise or more exact the measurement actually is. Okay, so let's talk about our measurement system. A real quick review. In science, we use the International System of Units, which is called the SI unit or SI system, also known as the old metric system. So in this system, we are not using inches, we're not using yards, we're not using feet, we're not using pounds. Instead, we would use like meters, centimeters, grams, milligrams, centigrams, degrees Celsius. So in science, we are going to stick with the International System of Units, or the SI system, or the metric system. So when we are talking about length is a measurement of distance. Our base unit for length is the meter. And then what we can do is we can go ahead and put these prefixes on our base unit to make our measurement or our units smaller or larger. So if the meter is our base unit, a millimeter is actually smaller than a meter. A centimeter is smaller than a meter. A decimeter is smaller than a meter. A kilometer or a kilometer is actually larger than a meter. So we can switch out these different prefixes to make our unit large or small depending on what we're actually measuring. What you would use to measure length is a metric ruler or a meter stick. If you guys, I'm sure you've seen a meter stick before. I've got a bunch of them in my classroom. The next measurement that I want to talk about is measurement of mass. Mass is how much matter is in an object. In the SI system, the base unit is actually the kilogram, which seems a little strange because it actually already has a prefix on it. But the kilogram is the base unit, so we can switch out this prefix with other prefixes in order to get our base unit larger or smaller, depending on what we are measuring. Most of the time we use grams. Kilograms are fairly large. The gram is just about perfect for measuring things in the classroom, measuring different substances. So all of our electronic balances that we use are calibrated in grams. So what we would do is we would switch out these prefixes in order, again, to make our units larger or smaller, depending on if we are measuring things that are larger or smaller. And we'll talk about a little bit more about the metric system, just not today. The SI system or the metric system, I think I'll go back here, is really easy to use because it's based on the powers of 10. So you have to divide or multiply by 10 to get a larger unit or a smaller unit. So it's very easy to work with. I'm sure you guys remember King David, what was it? King David died drinking chocolate milk. That's a good way to remember those prefixes. And we'll talk about that a little bit later. A balance is what we're going to use to measure mass. We have electronic balances. You may have in the past used triple beam balances, but we do have electronic balances that we would use. Okay, a few more measurements in the metric system. So volume, if you are measuring volume, volume is the amount of space an object or substance takes up. A few ways you can measure volume. First of all, if you are measuring milliliters or liters, okay, that means you are measuring a liquid. A liquid can be measured in a graduated cylinder. If you guys remember, you know, this is your graduated cylinder. You have your little markings here, right? You pour your liquid in and you have a curve. So graduated cylinder is going to measure volume, which is the amount of space an object takes up, if it is a liquid. There we go. If it's a liquid, you're going to use a graduated cylinder, and your volume would be measured in liters and milliliters. The liter is the base unit. Anytime you see centimeters cubed, millimeters cubed, or kilometers cubed, that means that you are dealing with a solid. So in order to get the volume of a solid, what you're going to do is, I'll see if I can draw something here. You're going to take the length, the width, and the height. So if you have a fairly regular shaped object, you're going to take the length, the width, and the height, and you're going to multiply the three of them together. Length times width times height, and that will give you the volume of a solid object. So anytime you see centimeters cubed, millimeters cubed, kilometers cubed, that means somebody has taken the length times the width times the height to find the volume of the solid. If you have an irregular shaped solid, then what you're going to go ahead and do, like a marble, for instance, you don't have the capabilities of measuring the length, the width, and the height. So what you're going to do is you're going to use water displacement method. If you remember, water displacement method. Okay, so the water displacement method, so let's say, I'm going to change colors here. Let's say I take a marble. First of all, let's say I measure this at 50 milliliters. I take my marble, I drop it in the bottom, and what happens is my water moves up, my water becomes displaced, and so now let's say I have 55 milliliters of water. So in order to figure out the volume of my marble, I'm going to subtract the two. So 50 minus 55 is 5 milliliters. So now I know that the volume of my marble is 5 milliliters. This is called water displacement. Okay, a few more measurements in the SI system. First of all, time is going to be measured in seconds. That's in base seconds or milliseconds. Those are the main ones. You don't see centiseconds. You don't see deciseconds. So for the metric system, you're going to use seconds or milliseconds, and we would use a stopwatch. And temperature is another measurement in the metric system. The base unit is the Kelvin. I'm sure you guys have heard of that in the past, but in the lab, we're going to use Celsius. All of our thermometers are calibrated in degrees Celsius. Fahrenheit is something that you would see the weatherman talk about, but if we're finding the temperature of something in the lab, we are going to use Celsius. But if you were writing a scientific paper, your temperature would be in Kelvin because Kelvin is the base unit. Okay, so moving on, I want to very quickly talk about the best way to take measurements. So the best way to take measurements is you have to read exactly what you see on the measuring tool, and then you're going to estimate the very last digit. My video might run out, so I'll make a second one and add it to this. So be patient and make sure you're watching both of them. Make sure you're writing notes down. Okay, so let's say, for instance, I have an object that falls right. Let's go back. There we go. Let's say my object is right here. Here it is. It's right here. My object falls right here. So what I'm going to go ahead and do is so if my object I'm measuring falls right here, then I am going to be able to read off of my measuring tool directly 1 centimeter, 2 centimeters, 3 centimeters. So I have right now, I can measure exactly 3 centimeters. So this would be 3.1, 3.2, 3.3, 3.4, 3.5. So I'm reading 3.5 directly off the measuring tool, but I always have to estimate my very last digit. So if I have something that falls directly on my tick mark right here, I'm going to estimate 0. So I can read it directly off the measuring tool all the way up to 3.5. So my estimated digit is the 0. If I have it right here, let's say my tool ends right here. So I can read exactly 1, I can read exactly 2, I can read 2.1, 2.2, 2.3, and then I'd have to estimate where it falls because I don't have a tick mark. So 2.3, and it's an estimation. It's in between the 2 marks, so I'm going to say 2.5 centimeters.